Hey all, my name is Gaurav Mandal. We are from Group 18.
Hi, my name is Christopher Jones.
I'm Bilal.
I'm Paul.
I'm Nivhan.
Okay, and today we will be discussing our first group assignment. So given that the population index is 1 out of 1000 and the statistics of mammogram test, we can go about explaining a patient that the test will be positive 92% of times given she actually has the disease. And if she does not have the disease, and given that the specificity of mammogram is 95%, the negative test means that the test will be negative 95% of times if she does not have the disease.
Yes, and using these parameters of specificity, sensitivity, and incidence, we can construct a contingency table as seen here. In the lower right-hand corner, there's a total population of 1,000. Of that 1,000, one person has the disease, and under 999 do not. So using the sensitivity, we can calculate what portion of that expected population that has the disease will result from the test, as is seen right here, of 0.92, and not having a negative test, but still having a disease of 0.08, which is our false negative. On the right side of the table, we can apply specificity to the true negatives, or true expected negatives, which is 999, and we can get these two numbers being the false positive in this corner and the true negatives in this corner. And using this contingency table, we can further elaborate to produce the positive predictive value and the negative predictive value.
Our patient wanted us to calculate the probability of having breast cancer based on having a positive test. Well, we can use a Bayes' theorem for that, which allows us to calculate probabilities based on knowing previous probabilities. So we can say the probability of having breast cancer for a test, dependent on a positive test, is equal to the probability of having breast cancer and a positive test divided by the total probability of having a test positive. So when we plug that into the equation, we see the rate of disease times sensitivity divided by the sum of the rate of disease multiplied by sensitivity plus the rate of no disease multiplied by the false positive rate.
So the way that works out is, since the rate of disease is 1 in 1,000, that gives us 0.001, and the sensitivity is 92%. So you multiply 0.001 divided by times 0.92. And the same thing goes in the denominator, and then you add the rate of no disease, which you calculate by subtracting the rate of disease from 1. That gives you 0.999. And where you get the false positive rate is subtracting the specificity from 1. So 1 minus 0.95 would give you 0.05.
So when you go back in to plug and chug all those numbers, we get 0.00092 divided by 0.0092 plus 0.04995. And that's going to come out to approximately about 0.0187. Multiply that by 100 to get 1.87, or roughly 2%. So with regards to this patient's question, she has a 1.87% chance of developing cancer throughout her life.